Hi there. In this video tutorial, I'll show you how we can perform test operations on files and directories. For example, I have these files in my current directory. Let's create a sample directory. Let's give it name test. Now the current listing of my current directory looks like this. In my previous tutorial, topic number 4, I have shown you that we can use this pair of square brackets to perform tests. So let's use -f test operator to perform a test on a file name or on a directory name to see if the specified file is a file or not. As we know, everything in Unix or Linux is a file. Even if it's a directory, it's a file. So we say file type file, file type directory, file type link, soft link or hard link. Here I specify this file name demo in my current directory. I hit the enter key and let's see the result status or the exit status of the last command executed. As we know that 0 means successful, any other number means warnings or errors or simply not successful. So we have confirmed that the type of this file demo named here is file or is a regular file. Let's see what happens if I provided this test directory name. It should not be 0. Yep, it's not 0. That means the file type of the file mentioned here is not regular file or file. It's a directory instead. So if I use -t operator instead, which confirms if the mentioned file is of type directory or not. So in this case it should return 0, meaning successful. Let's create a soft link to this file demo and let's name the link T. Let us confirm. We can see the file demo is already present and we have created a soft link to it and we have given it the name T. There is this command file which also confirms the type of a file specified. In this case I am using the soft link's name here, which is T, and it tells me the file T is of type symbolic link and it is linked to this file demo. Let's create another symlink or soft link and give it name T. The test directory in my current directory is already present. So we have created the link named T and it is pointing to the directory test. Let's again use the command file and see what it confirms. So it says the file T is of type symbolic link and it is pointing to test, which is a directory. The first letter here, T, means it's a directory. In the case of this file demo, the T is missing here, a hyphen is there, that means it's a regular file. In case of symlink, the L here and the L here, this L means it's a link or symbolic link. Let's perform some more file tests. Let us create a simple file containing a few words or lines. Let's give it name demo. Hi there. I have saved the file. Let's confirm the contents of the file. Okay, the file is present and it has got some data inside it. Let's also create a dummy file or a blank or an empty file. Let's give it name empty. Let's see. So we got two files. Demo has some data and the other file empty, which has no data. That's why it's of size 0. The Hyperness operator will confirm if the specified file is empty or not. So Hyperness means it should have some data. If it has some data, it will return 0. So it's returning a non-zero value here. We can see 1 in this case. That means the file is not empty. Let's try it with the other file which has some data. So this time the value should be 0, which means the file demo has got some data, as we can see here. We can also use the keyword test to perform file types. Here the test operator without any option is confirming whether the specified file or directory exists or not. So even if I give it a file name or a directory name without any options, it will confirm if that item is present or not. So in both cases, in case of a file name and in case of a directory name, we see the return value is 0, which is successful. Here, in this case of F operator and the file name being demo, it's returning 0. That means the file type of the file demo is file or regular file. In case of the directory tests, we see the return value is not 0. That means it's not a file, it's a directory in this case. Here Let's use -t and see if it returns 0 this time. Yes, it does, because the directory is present and it's of type directory. Let's clear the screen and see the contents of the current directory again. We can see that some files are older. Here, this file, check num arguments.sh, it's a shell script. It is older than this file empty. So we can perform those tests as well. Let's say older than OT. So we need to specify file 1 and file 2. File 1 is, in this case, check number arguments is older than the other file named empty. Let's see the result or exit status, which is 0, which is true because the file empty is newer than this one. We can use anti for newer than, but in this case it will return a non-zero value, meaning the statement is not true. So we can simply reverse the order of these file names. In this case, empty is newer than check number arguments .sh echo $, and we see it's successful. We can use the command test as well, and we get the same output here. There are many options available, or operations or operators that we can use with the test command or test operator or the square brackets as shown here, or we can use test command. Let's see what other options are there. I'm using the man command to see the manual of this command test or test operator. Test and expression. Expression is generally a logical test, and we see here that what it does, it checks file types and compare values. So we can also use an exclamation sign in our expression to negate the overall expression or condition. We can also use -a in between two expressions to mean that both conditions should be true. We can use -o to say that either the first or the second condition should be true. We can use -n with a string variable, and this will confirm that the variable containing a string is of non-zero size. So that means it has some values. Similarly, -chat will confirm if a variable is not having any value, that is its size or length is 0. In my previous tutorial, topic number 4, I have shown you how we can compare numbers or strings. Here we see more operators and test scenarios. -b to see if the file is a block special file. Similarly, -c means it's a character special file. We have seen D, we have seen F. -e means whether it's a directory or it's a file or whatever it is, it must exist, and accordingly it will return the status. So all these options are operators are available. We have seen this small s, that the file is specified exists n and it has a size greater than 0. So you can refer to this manual page using the man command. Let's see how we can use the -e operator. Let's specify any of these file names. For example, T. It will confirm whether this file exists or not. It's returning true. 0 means yes, the file exists. I'm giving it some other name. It doesn't matter whether it's a file or directory. It will check for its existence only. And as you know, there is no such file in my current directory called type. So we should see a value which is not 0. If I create a file with this name and run the test again, I should see 0 now. So just to conclude that we can use the command test, or we can also use the inbuilt test operator, which is the opening and the closing square brackets, and perform several test operations on variable name, on the values of variables, on file names and directory names. This becomes very helpful when we are writing a shell script, and from within our script we want to make sure that a certain file exists, or a file name that has been provided by a user is valid. So let us write a shell script now and see how we can make use of these test operators inside a shell script. File test.sh. let's set the executable permission onto our script. Let's confirm our script is here. Let's see the contents of our script. So we are using the test command and we are expecting a parameter or command line argument passed to our script, and that argument or value is simply a file name, and inside our script we are checking if the file name provided is specified is of type file and it must be present. So $question mark will return value 0 if the condition returns true. So I'm checking here if the return value is not equal to 0, then double ampersand signs here mean then run this piece of code or command. So my echo command will print this message. As we know, the first argument or value passed to our script is stored in the variable system variable or environment variable called 1 or number 1, and using the prefix dollar we are actually accessing that value. So now let's run the script, and we are not giving any file name or directory name, and we see no output. Because we have not designed our script to handle this scenario, which we'll do shortly. Now let's provide a file name. In this case, I'm providing this file name type, which is an empty file, but that should work because we have used the -f operator to see that the file exists and that it's of type file. We see no error. Now let's see if this works, because this file does not exist, and we see the error now. The file types does not. Let us edit our script. This time we want to make sure that we get at least one argument passed to our file or script, and if it is not present, that is no argument is provided, then throw a message and then exit. As we know, $# gives us the count of total arguments or values passed to a shell script. So we can check that if it is less than 1, that is 0, then print this message and exit. Let's also give it some return code, a non-zero value. Now I type in my error message, insufficient command line arguments. Please note that as I intend to run multiple commands in this scenario, I'm using this pair of curly braces so that I can run more than one command as a group. So my echo command will be executed. I have specified semicolon here to separate it from the next command, and the next command is exit. Please leave the last semicolon as it is, the way I have done here. So if no value is provided, this message should be printed out and my script should exit with the return code of 100 as it's not successful. If I provide a file name, then this check will return false and this part will be skipped. Then the test operation will be carried out, and accordingly this message will or will not be printed out. Let's write and quit. Let's run the script without any argument, and we got the message, and we should see 100 as the returned value. As the value is not 0, our operation was not successful. Let's give it a file name this time. We can give it the script name as well because it doesn't make any difference. We see no message because our script will complain only if the file name provided is not of type file or is not present. Let us see if we are trying to copy one file to another location the way we do with the help of cp command. I have file here, file underscore test.sh, and if I give it some name like test.sh, it works fine. If I don't give it a destination, then it complains because it requires two items or two values, source and destination. So it is saying missing destination file operand after the source file, file underscore test.sh. Let's make use of the cp command inside our script. We edit the same file. This time we are expecting two file names. So we'll change the value, and we want to make sure the first file is present and is of type file so that our cp command can work. If that is not the case, then throw this message and exit. So to perform multiple commands or actions, we can again make use of the curly braces and run multiple commands as a single command or as a group of commands. We exit with the return code of 100. If all goes well, then run the cp command, use $1 as the source and use $2 as the destination. Let us run the script in debug mode and see how things go when we execute this script. I'm providing it a source file, let's say file underscore test.sh, the script itself, and a destination, let's say some name .sh. I hit the enter key. Here you see, let's also print out the source. So our first statement is checking for the number of arguments passed to it, that is passed to our the first statement here is checking that we got at least 2 arguments. So we see here the value returned by $hash becomes 2 here, and we already have this constant 2 less than 2, which is false. So this part is not executed, it is skipped, because ampersand here stands for the true condition or true part. We have not provided the false part here or the else part. Now we are performing a test whether the source provided exists or not. So we see the return status is 0, and the test in the next line says if the return status is not 0, then do this. So because the return status is 0 and the test says not equal to 0, which becomes false, so this part is also skipped. And so we move on to the final command line, which is a cp command. $1 is substituted with the first argument, which is file test.sh. We see here file underscore test.sh, and $2 has been replaced with the second item someone.sh, and we see that both the files are there and the new file has been created. That's all for this session, folks. Thank you for watching.